Math Simplified. This video is for 9th standard students. We are studying the 4th chapter geometry. Today's topic is circles. We are going to do exercise 4.3. Please subscribe and share with your friends also. Circles. A circle is a set of all points at a constant distance from a fixed point. The fixed point is called the center of the circle and the constant distance is called the radius of the circle. So this is the figure of a circle. So you can see this is the center and this distance is called the radius. And this distance will be called the diameter. Okay, diameter is 2 times radius. Chord is a line segment whose endpoint lies on the circle. So this is an example of a chord. Diameter, a chord which passes through the center. So this chord, if it passes through the center like this, it becomes the diameter. Circumference, it is the boundary of the circle. Okay, like this. Arc, the continuous part of the circle between 2 points on the circumference. So supposing you take 2 points like this, then this is called the arc of the circle. Concentric circles, circles with the same center but different radius. So you can draw many circles with this center. They are all concentric circles. There is only one circle passing through 3 non-collinear points. Non-collinear points are, they will not lie on the same line, and we can draw a circle which passes through these 3 points. Properties of chords of a circle. So this is a circle and this is a chord. Okay, this chord will have some properties. Let's see. The perpendicular from the center of the circle to the chord bisects the chord. So here from the center, if you draw a perpendicular like this will be 90 degree and it will bisect the chord. That means this AD is equal to DB. Okay. Equal chords of a circle subtend equal angles at the center. Supposing there are 2 or more chords which are equal in length on the circle, and if you draw lines like this angle is subtended at the center. All these angles will be equal. Okay. Equal chords of a circle are equidistant from the center. So supposing there is another chord which is equal in length and you draw like this, it will have the same distance as this distance from the center. The angle subtended by an arc of the circle at the center is double the angle subtended by it at any point on the remaining part of the circle. So supposing you take this arc, AB arc, it subtends an angle here. Okay, this angle. Now this arc can subtend any angle on the circle also. Supposing this is the point here, then this angle will be half this angle. That is, this angle at the center will be 2 times the angle at any point on the circle. Angles in the same segment of a circle are equal. So here, if there are 2 points on the circle, then the angles on the same segment, you can draw so many angles, they will be always equal. Okay, let's go to the exercise 4.3. The diameter of a circle is 52 centimeter and the length of one of its chord is 20 centimeter. Find the distance of the chord from the center. So here, this is a circle, this is the center, here is a chord. We draw a perpendicular line like this to the chord. This will divide this chord into 2 equal parts. So here they have given the length of the chord as 20 centimeter. So this distance will be 10 centimeter. Diameter of the circle is 52. So the radius is 52 upon 2, 26. Okay. Now we have to find this distance from the center to the chord. This triangle is a right angle triangle. So by Pythagoras theorem, this distance OD is equal to square root of 26 square minus 10 square. So this is 676 minus 100, square root of 576 is equal to 24. So this distance is 24 centimeter. Okay, second sum. The chord of length 30 centimeter is drawn at a distance of 8 centimeter from the center of circle. Find the radius of the circle. Okay, so here the length of the chord is 30 centimeter. So this portion will be 15 centimeter. This is the perpendicular drawn on the chord. Okay, and that is 8 centimeter from the center. So this OM is 8 centimeter. Now we have to find the radius, which is the hypotenuse of this circle. Okay, hypotenuse of the triangle. So hypotenuse is square root of 15 square plus 8 square. That is square root of 289. That is equal to 17. So the radius is 17 centimeter. Okay. Question 3. Find the length of the chord AC where AB and CD are the two diameters perpendicular to each other of a circle with radius 4 root 2 centimeter, and also find angle OAC and OCA. So okay, these are the two diameters, and this angle is 90 degree. See, they are perpendicular to each other. So this angle is 90 degree. They have given the radius as 4 root 2. Okay, so we have to find the length of the chord AC. So this is very easy. This triangle is a right angle triangle. So by Pythagoras theorem, AC square is equal to 4 root 2 whole square plus 4 root 2 whole square. So simplify it. AC square is equal to 64. AC is equal to 8 centimeter. So this distance is, the length of the chord is 8 centimeter. Okay. Now they are asking us to find this angles. Okay. So here we can say this angle A plus angle C is equal to 180 minus 90 degree. This is 90 degree. Okay. And both these angles are equal because this triangle is an isosceles triangle and the sides are equal. So 2 OCA. 2 times OCA is equal to 90 degree. So angle OCA is equal to 45 is equal to OAC. So this angle is 45 and this angle is also 45. A chord is 12 centimeter away from the center of the circle of radius 15 centimeter. Find the length of the chord. So this is the chord. It is 12 centimeter away from the center of the circle. So this distance is 12. Radius they have given as 15 centimeter. Again, take this triangle and apply Pythagoras theorem. So dB is equal to square root of 15 square minus 12 square. That is 81. So this distance we get it as 9. Square root 81 is 9. This whole chord is 2 times 9. So 2 9s are 18. So the length of the chord is 18 centimeter. Question 5. In a circle, AB and CD are two parallel chords with center O and radius 10 such that AB is equal to 16 and CD is equal to 12 centimeter. Determine the distance between the two chords. So here this is one chord, this is another. Length of this chord is 16 centimeter, length of this chord is 12 centimeter. Okay, so they meet in the center like this. Radius of the circle is 10 and 10. Okay, we are asked to find this distance FE. Okay, the distance between the two chords. First let us take this triangle. First let's find out this distance. This FO is equal to square root of 10 square minus 8 square. So that will be 6 square and this distance is 6. Okay. Similarly for this triangle, this distance will be square root of 10 square minus 6 square. That is 64. Square root of 64, that is 8 centimeter. Okay. So now we have, this is 6, this is 8. So what is FE? 6 plus 8, that is 14 centimeter. So the distance between the two chords is 14 centimeter. Question 6. Two circles of radius 5 centimeter and 3 centimeter intersect at 2 points and the distance between their centers is 4 centimeter. Find the length of the common chord. Okay, so one circle, this circle I am taking as 5 centimeter. That is the radius of this circle. Okay, this circle is smaller circle. It is radius is 3 centimeter. But just to make this triangle look big, I have drawn a bigger circle. But in actually, this will be very small, and the distance between the two centers is 4 centimeter. So this is actually the center of the smaller circle. Can you see how small the circle is? But I have drawn it big so that we can see the triangle easily. Okay. So distance between the two centers is 4. So this will be, apply Pythagoras theorem. You will find that this value AD is 3. So what do we understand? And the length of this chord will be 3 plus 3, 6. So this chord is 6 centimeter. So you can see this is the center. This distance is 3. That means what? The diameter of this circle is this chord. okay, of the diameter of the smaller circle. So here I have just expanded the smaller circle to make this triangle look big. Okay, question 7, find the value of x in the following. So here they have given this figure. So this is 30 and this is 60. Okay, so here you can see that this arc, it subtends this angle at the center and this angle on one point on the circle. Can you see this? This is the angle subtended at the center by this arc. So this angle at the center will be 2 times this angle. Okay, so x is equal, so what is this angle? Total angle is 90 degree. Okay, so x will be 1 upon 2 into 90 degree. Okay, so you get the value of x as 45. So you remember that rule, that the angle subtended at the center will be 2 times the angle subtended at any point on the circle. Okay, question 7.2. Okay, there is another figure here and this is x. We are supposed to find this value. Okay, they have given us these values. So here we can see that this angle 80 is subtended at the center, and so the point here on the circle, the angle subtended by this arc will be 80 upon 2, that is 40 degree. Okay, so we found P as 40, angle P 40. This angle R will be 50 plus 30, that is 80. So we got angle P as 40, this as 80. Okay, so what will be this angle? This angle Q will be 180 minus 80 minus 40, that is 60. This full angle will be 60. Okay, now this angle will be equal to this angle because this is an isosceles triangle. Okay, so x plus 50 is equal to 60. Therefore, the value of x is 10 degree. Question 7.3. So this is the figure here. We are supposed to find this value of this angle x. They have given 110. Okay, so here let's see what we can do. MPO plus PMO plus this angle is equal to 180. Okay, so but these two angles are equal. Okay, so 2 times MPO. Okay, so 2 times this angle is equal to 180 minus 110, that is 70. So this angle becomes 35 and this angle is 35. So we found these two angles. Okay, now MPN is equal to 90 degree. Okay, this is another rule you should remember. Supposing this is the diameter. Okay, this is the diameter and any point here, the angle here will be always 90 degree. So this angle plus x is equal to 90. Therefore, x is equal to 90 minus 35, that is 55. Okay. Okay, and this is another method I have done, but this itself is sufficient. Okay. 7.4. Central angle is twice the angle subtended on the circumference. Okay, so here this is the figure and they have given that this angle is 240. Okay, so this arc subtends angle 240 on the center and this angle is 120. So this angle x will be 360 minus 240, that is 120. Okay, 7.5. So this is the figure here. We have to find this angle x. They have given 140 here and 100 here. Okay, so what is this angle? So this arc, it subtends this angle at the center. What is this angle? It is 360 minus 140 minus 100, that is 120. This angle is 120. So this angle will be 1/2 120, that is 60 degree. Okay. Question 8. In the given figure, CAB is equal to 25. CAB. This is 25 degree. Okay. Find BDC, DBA and COB. So these two lines, this is also given. This is a 90 degree. Okay. This is 25. Okay. CAB. CAB is 25. We have to find BDC. Let's see, where is BDC? BDC. Okay. What is this angle they are asking us to find? So this angle, see, this is the base. Okay. BC is the base. So can you see the angle which is formed here? 25. So if this is the base, any angle formed on the circle, at any point on the circumference will always be 25. That is the rule. So from this base we can draw many angles 25 with 25 degree. So definitely this angle is also 25 because BC is the base for these two angles. Okay. Next is DBA. We have to find, this is DBA. So here let us take this triangle. We have to find this angle. Okay. We know that this angle is 90 degree. Here it's vertically opposite. This angle we just now found, it is 25. So 180 minus 90 minus 25, 65. So this angle is 65. DBA. Okay. Then COB. COB. Okay. So this is the angle subtended at the center by this arc. Okay. And this arc subtends angle 25 here on the circle. So this angle at the center will be 2 times this angle. So 25 into 2 is 50 degree. Okay. So here we come to the end of the exercise. Please go through the exercise once again. Pause the video in each sum and practice them.